This question says, for each system listed in the first column on the table below, decide, if possible, whether the change described in the second column will increase the entropy of the system, decrease the entropy, or leave the entropy unchanged. And you may not have enough information to decide. So the first thing it says is a few moles of nitrogen gas. So we have a few moles of nitrogen gas, and the nitrogen is cooled from 29 degrees C to 10 degrees C while the volume is held constant. So we have a constant volume, so the entropy does not change because of the volume. The entropy only changes because we cool it down. When you cool something down, the entropy decreases. It becomes less random. So in this case, delta S is less than 0. The system becomes less random, so therefore delta S is less than 0. Or a negative number is another way of saying that. Here we have a few grams of liquid acetone. So we have acetone as a liquid. And then the acetone evaporates at a constant temperature, 55 degrees C. So we're essentially going from a liquid to a gas at constant temperature. A liquid, the molecules are relatively closely packed together and less random than in a gas, where the molecules are much farther apart. So when you go from a liquid state of matter to a gaseous state of matter, entropy increases because randomness of a gas is much greater than the randomness of a liquid. Let's look at the last case. A few moles of carbon dioxide gas. The carbon dioxide is heated from -8 degrees C to 41 degrees C. So in this case, based on the temperature change, we increase the temperature, so delta S should be greater than 0. And is also compressed from a final volume of 9 liters to a volume of 1 liter. Now we have the gas in a much larger space going to a much smaller space. In this case, it's going to be less random because it's in a lot less space. So in this case, delta S is negative or less than 0. So the heating increases the entropy and the compression decreases the entropy. We do not know which factor is greater in this particular case. So in this particular case, we have conflicting variables going on here. One it's positive and one it's negative, so we don't have enough information to know the overall change in entropy for this process. So this is basically how you want to evaluate this type of problem.